Greetings all and salutations. Welcome to the first Stormwater Fundamental Series for 2025. How exciting. Another super popular webinar today. Last time I looked, we had 641 registrations. So that's 641 now. A lot of people think I make these numbers up. I promise you I don't. I'm happy to try and prove them that they are real, but and I can see everyone coming through the virtual turnstiles. Great topic, great presenter. Really looking forward to today. But before we kick off official proceedings, I'll give people a few minutes just to come through the virtual turnstiles because I can see them all coming through now. So welcome everyone who's joining. Um, just a few quick sorry, first up, I guess we should acknowledge the fact that this is the first of the Stormwater Fundamental Series for 2025. It was super popular last year, hence oh, I'm getting a message that people can't hear me. Is that correct? Can I get a thumbs up from someone if they can hear me? Uh, cool. So yeah, lots of thumbs up. I can hear you well. Thank you. So apologies to I think Kareem has said can't hear you, can't hear me. Look, that's not the end of the world. It's probably a good thing for most people. So thanks everyone for putting up their hand. A lot of people can't hear me, so I think it might be an audio issue at your end. So maybe give that a look over. But look, thank you everyone for just continuing to come along. We don't do this thing, and we wouldn't do this thing if no one turned up. But like I said, super popular session, 641 registrations, and it's following on from, I guess it all started last year. We thought there's a gap in, I guess, the industry. There's a lot of people need capacity building, just on particularly on the fundamentals of what we do, and and no one else was given sort of training, I guess, about stormwater fundamentals. So lo and behold, we decided to do it, and super popular last year. So we're doing it again this year, and we're getting a whole bunch of other presenters to come along. Obviously, Mukta from eWater Group coming along to talk about music today. But we've also got Sean Quilty, super popular presenter, joining us again to run through a few things. I think he's got three sessions. Then we've got Murray Powell, the legendary Murray Powell from Optimal Stormwater, coming along talking about stormwater treatment assets, as well as his colleague, esteemed colleague, Dan Rhodes, who's going to join us as well. We've also got Ian Adams from Organic Engineering coming along talk about integrated water management for buildings. And then a few Protect guest appearances as well, talking about a whole bunch of stuff. So, before we kick off proceedings, just a few quick things around some stuff happening at the Ocean Protect or industry front. If you're in Brisbane, there's a Queensland Water Summit happening next month. Ocean Protect are bronze sponsor. Tickets have actually just sold out, so we've reached capacity. 188 people have got their ticket. But we've actually decided, because so many people are on the wait list or want to join, we're going to actually live stream it as well. So if you're keen to live stream that event, just jump on that website there and just head to the tickets link. But yeah, super exciting. A whole bunch of groups collaborating on that one. I guess the big news from Sydney is Ocean Protect. We've moved. We've moved to a facility in Condell Park, so our precast manufacturing facility and our office-based staff are all under the one roof, basically, at Condell Park. So if you're in the neighbourhood, check us out. Come say hello. Um, the other exciting news is our urban pond technology. We actually only released that very recently, and we've actually literally yesterday, did our first installation. So can't actually tell you where it is because it's a bit secret squirrel. But if you want to know more, reach out, or if you want to find out more about urban pond, just click on that link below. But fundamentally, it's about underground detention, which is pretty cool. There's been a heap happening on the Filterra bioretention front. We've literally just last week finished planting out the two biggest Filterra bioscapes ever in Queensland. The biggest of the two is just under 300 square meters. The other ones are just under 200 square meters. And literally yesterday, a lot of stuff happening. Yesterday, we actually started installation of what we believe is the biggest Filterra bioretention in the world. So that's around about 990 square meters. So just under 1,000 square meters Filterra bioretention. If you want, and obviously we had squid verification confirmed in late last year. So if you want to know more about Filterra, just reach out or just head to that website. It's just in terms of a few housekeeping things. Mukta's going to do an amazing presentation, I got no doubt. If you do have any questions, please put them in the Q&A panel. It's generally a case of first in, best dressed. Please don't put your questions in the chat. You can put in your, hey, hello, and thumbs up, all that stuff in the chat. But if you do have a question, please put it in the Q&A. It's just a lot easier for us to handle and manage and get to it, essentially. Just a reminder, also, the slides of the preso and the recording will be made available on our website generally within about 24 hours. And in the terms of CPD forms, and this became bigger than Ben-Hur last year, we get so many CPD form requests. We've actually streamlined it a lot this year. So as part of the registration, if you wanted a CPD form, you would have let us know known as part of the rego. So for those people who have, we'll send you the CPD form within probably a week. If you haven't received it within a week, just email us and we'll make sure you get it. Cool. But without further ado, I might pass you on to the presenter for today. And Mukta, you're welcome to share your screen. But whilst you're doing that, I might just introduce Mukta. But it's very exciting. It's our first presentation as part of the Fundamental Series from anyone. Let me just check if I can. So yeah, you're enabled. You're okay to share the screen if you like, Mukta. I might stop sharing my screen if it's easier. But there we go. But if those who aren't familiar with Mukta, she's a senior hydrologist at eWater. She's got many, many years experience, well over 15, both Australia and overseas. And she actually regularly conducts training for the eWater music courses. But this is obviously the first time we've had her as part of the Stormwater Fundamental Series. So welcome, Mukta. Can I just check a couple of things on the technical front? Mukta, can you hear me?
Yes, I can hear you, Brad.
Yeah, and I can hear you too. I've just had a couple of messages from a few people saying they can't hear the presentation. If you can't hear, it seems like I can see a whole bunch of hands going up. So can I just get someone in the chat just say, yeah, we can hear you? Okay, great. Sweet. You just want to double check. I've just had a couple of people saying they can't hear us. So it all sounds good. Awesome. Thank you so much for everyone in the chat. Much appreciated. It makes it a lot easier. Otherwise, we're wondering whether we're talking to anyone can hear us. So without further ado, I'm put you in the tender care of Mukta. But just a reminder, folks, if you do have a question, please put it in the Q&A for Mukta. But take it away, Mukta. Thank you so much. And as a side note, thank you so much for giving up your time to present today. And certainly thank you to eWater as well for their support in putting this thing on today.
Thank you so much, Brad. And I'm now going to start my presentation. Hello, everyone. Thank you for joining us today. Before we begin, I'd like to acknowledge the traditional custodians of the land from which we all join today and pay my respects to elders past and present. Today, I'll be introducing you to the music software for stormwater modeling and its applications in urban water management. Before diving into music, let's explore how urbanization impacts catchments. So when we usually urbanize, several changes occur, starting from removal of vegetation, then increased in hard surface, that means increased in imperviousness. We also introduce so-called efficient drainage system to quickly remove water from one urban environment, taking that to some other downstream waterways, and that was basically driven by the need to manage flood risks in the area. In this process, we also actually introduced a couple of new pollutants. You can see in this picture a lot of cans, plastics, that sort of waste. We introduced organics, bacteria, nutrients, heavy metal, hydrocarbons, and we also increases existing contaminants compared to the natural water what you have. Now, what that does is in terms of your hydrology, this really changes a couple of things. It's starting from altered hydrology, erosion, water quality degradation, and ecological disturbances. Let's start from change in the hydrology aspect itself. So if you look at this diagram here, you can see this column line here represents the rainfall events or precipitation. This bold continuous line, as you can see, this is runoff for your natural or forested stream. And this dotted line here, continuous line, this is again runoff generated for urban stream. And if you compare these figures, so first of all, if you compare between forested and urban runoff, you can clearly see urban runoff will have very less low flows. So low flows from your natural catchment will be quite good compared to your urban catchment. Next thing you can notice here is for your forested catchment, it only responds towards few very high rainfalls, and that response is also very, very less. Compared to your urban catchments, it is like responding to almost all these different rainfall events. And what does that mean is it will increase the frequency and magnitude of your peak flows. Next issue is channel formation. So we wanted to control where the water is going, managing the risks, and we call it so-called very efficient. But what is really interesting to note it here is we try to move out water quickly out of one urban environment, and it has actually quite a big consequences downstream over time. This photo here, you can see there is obvious sign of channel erosion, and then another problems you can also see is sedimentation. Next issue from your urbanization is the water quality degradation. So urbanization increases the existing contaminants, and it also actually introduces new pollutants, as I mentioned earlier. And what does that do is it then creates whole bunch of problems. It reduces aesthetics. You can see some example here. It also make water toxic. There is algal blooms happening, blockage in the drainage system, and all those sort of issue arises from degradation in the water quality. And finally, this altered hydrology and also more pollutants in water then disturb overall ecology. Now, fish there, for example, they need certain level of water in the breeding season, and they can't really survive in that season at all. So there are whole bunch of consequences for our aquatic life as well. So now what we want to do then. So to address this challenge is we use water sensitive urban design, or WSUD. The aim here is to replicate the natural water cycles and improve water quality. These WSUD principles focus on protecting natural features, maintaining hydrology, reducing reliance on external water supplies, and integrating water into urban spaces for multiple sort of benefits. Let's see what exactly that means in terms of your water cycle. So in the natural water cycle, if you look at here, infiltration, evapotranspiration forms a huge part, and only less amount of less polluted surface runoff is generated. But when you look at your typical urban catchment, you can see there is reduced infiltration because of increase in hard surfaces, reduced evapotranspiration as there is loss of vegetation, and then there is increase in poor quality of runoff. And to add to this, we also change the water balance again by importing some of the potable water to feed the city, and then that again comes up with some wastewater discharge as well. So what WCT does is this water sensitive urban design incorporates features like reuse of water, as you can see here, and stormwater to create a sustainable and balanced urban water cycle. Implementation of this WSCD aims to recover or improve the disturbances within the water balance by increasing vegetation cover. So once you increase the vegetation cover, that means you are also increasing the evapotranspiration. It also tries to increase the infiltration, and as a result of it, another thing what we do is we also try to have this stormwater reuse, so that you can see your runoff generated from the overall surface will be less. And one major part is stormwater treatment, and that is where music comes. So now that we have introduced urbanization impacts and then water sensitive urban design, and also we had a bit of look at how it can actually restore the water cycle, let's talk about why we actually need a more link to like music. So managing the impacts on our urbanization on receiving water is a complex challenge. It requires an integrated approach, as urban water managers must navigate multiple considerations, including the effect of land use change, the performance of various water-sensitive urban design features, and evaluation of various stormwater treatment measures to meet regulatory compliance. And to tackle these complexities effectively, we need a robust tool that can provide reliable insights and support decision making. And this is where music comes in. It is designed to help us navigate these complexities and achieve better outcomes for our waterways. So now let's have a look at what exactly is music. So music is the model for urban stormwater improvement conceptualization. It is a powerful software tool designed to simulate urban stormwater flow and quality. It models pollutant generation, transport and treatment, and offers probabilistic assessment of water quality outcomes. You can run music at a range of scale, both spatially and temporally, from years down to 6 minutes and from 1,000 hectares down to a single lot. So music actually models the way pollutants are generated, how they are transported through the steam network, and how they are influenced by the various treatment measures that you are going to use. Now, next thing I would like to show you, from the software perspective, how exactly music interface looks like. So as you can see here, music uses a graphical user interface which helps modelers quickly and visually build models. And consistent with, again, other hydrologic models, music uses, you can see, node and link architecture to describe how runoff and pollutant generates here, and how that is transported to the treatment measures, and then goes to your catchment outlet, which we call in music as a receiving node. Next, I want to show you a couple of nodes in music and also links. So starting from the source nodes. So in music, source nodes define the catchment or subcatchment characteristic that can impact on runoff volume and quality. And these source nodes in music are driven by climate data. Climate data here are rainfall and evapotranspiration. So based on this climate data, that is rainfall is converted into a runoff time series. And also we have some pollutant characteristic, and that also helps in generating pollutant time series, which is then routed through the catchment to be delivered to the catchment outlet or treatment device. So this is how these source nodes work. Next one is drainage links. So in music, drainage link, as you can see here, control the movement of water as it passes from the source node to the treatment devices or source node to the receiving nodes. And you can now model these links as a direct pass through. That means no routing, or if you want to use a more detailed routing algorithm to adjust the way flow and pollutants are transformed as they move, we have this storage Muskingum routing is also actually there. Now, next, I would like to talk about a little bit on process modeled in music, starting from rainfall runoff process itself. So in music, we have implemented this Chew and McMahon 1997 model. So what happened in this model is the conversion of rainfall to runoff is done using this bucket style model where moisture stores are represented by various leaky buckets and they are sized according to the catchment conditions. So let me explain a little bit more detail here. So if you look at music, like, it first of all divide your impervious and surface or pervious area separately. From your impervious storage, if there is any rainfall event, whatever comes in after this rainfall threshold will then generate surface runoff, which we call as a impervious surface runoff. You can call it as event runoff as well, because that is more like, once you have event, then that is going to be generated. Within pervious storage, what happens is, first of all, it tries to fill this store completely until it is fully saturated. And then the rest of it will now again just like, generate a surface runoff, which we called in music as a pervious surface runoff. So this impervious and pervious surface runoff are event runoff generated depending on the rainfall event. Now within here, depending on, like, your soil characteristic and also your groundwater characteristic, this pervious storage will contribute some water towards groundwater, and this groundwater then contributes some water towards the base flows. You can call it low flows or dry weather flow, because this is not a rainfall dependent event. So this is the, like, how rainfall runoff is modeled in music. Next one I would like to show is, like, pollutant generation. So in music, pollutant generation is handled using an EMC DWC approach. So EMC is event mean concentration. So you already saw in my earlier slide that there are, like, two type of runoff, event runoff and dry weather runoff. So we implement this event mean concentration for event runoff, and for your base flow, we implement this dry weather concentration, and this is implemented for all the contaminants, and music can handle total suspended solid, total phosphorus, and total nitrogen. Music also can handle gross pollutant, but for gross pollutant, we use a logarithmic equation as a function of flow for generating the gross pollutants in music. And this gross pollutant generation is based on this, again, Ellison et al. Research. And then this another, like, EMC DWC approach. If you are interested, there is a reference provided based on this Duncan 1999. Now, once, like, contaminant generation, runoff generation, next is treatment. So I'm not going to cover a lot on this one. I'll just, like, give you a very quick view on this treatment. In music, we use USTM approach. So this is called Universal Stormwater Treatment Model approach. So what is done here is we combine three basic modeling process. So first one is hydrologic routing. So we use hydrologic routing to simulate the movement water through the device. So there will be, like, flow coming in, then from your device there will be different type of flows going out, such as high flow bypass, even, like, before going to device, it will just bypass the device, and there will be overflow happening, there will be treated outflow, reuse. So these all, like, different type of thing is called hydrologic routing. So we implement hydrologic routing to simulate the movement of water through the treatment device. Next is treating the pollutants itself. For treating the pollutants itself within the device, we use first order kinetic model to simulate the removal of pollutants within the treatment system. And on top of that, we also use this CSTR, which is continuously stirred tank reactors, to describe the degree of mixing of flows within measures. Like, there can be some disturbances when flows come in. So somehow to include that, we also include that CSTR number. And music combine these different three principles, which I just mentioned now, into a single versatile model. And the same algorithm is used for most of the devices, including sedimentation basin, pond, wetlands, soils, and temporary ponding of a bioretention system. And we just, like, achieve our target, changing, like, a couple of inputs here. Now, as we talk about stormwater treatment nodes, let's have a look at, like, what sort of treatment devices actually you can achieve from, like, music itself. We offer a large range of treatment nodes in music. So you can see here, for example, buffer node, bioretention, detention basin, infiltration system, media filtration, pond, rainwater tanks, sedimentation basin, swale, wetland. And within music, each of these inbuilt measures can be configured in accordance with the conceptual representation of the model. You can see here is an example of wetland. You can see the plan view and longitudinal projection, and this is where you can configure this according to the conceptual representation of the particular measure here. Now, if the inbuilt nodes are not sufficient, then we also offer generic treatment node. So it then allows much more flexibility in terms of simulating other practices, such as you might have cross pollution trap and so on. So you can use this generic treatment node to simulate the practices as such. So as mentioned earlier, the generic node can be configured to simulate a range of elements, including flow bypass treatment, point source discharge, stormwater harvesting, increased pollutant generation, and a whole range of other techniques. Next thing is within music, you can also actually model water reuse within those treatment devices. So where the stormwater treatment measure has some water storage available in the form of permanent pool, then water reuse can be turned on to simulate the removal of water that would occur. And you can configure this reuse in several different ways. You can have annual demand. Again, you can have that annual demand scale to potential evapotranspiration, or if you want to have it distribute monthly, you can do that. You can have just one basic daily demand value, or if you have your own defined input file, you can also bring that in to define your water reuse. Next, I'm going to talk about what sort of model outputs or results you will get from music. So music offers a range of output options representing the model data both visually and quantitatively. Starting from time series graph. So in music, you can get all of these flows and contaminant concentration, contaminant load graph for various flows. For example, you already see from your rainfall runoff model, you have impervious flow, pervious flow, base flow. So you can get all different type of contaminants time series and flow time series for those different flows. Similarly, if it's a treatment device, you can again get high flow, overflow, treated flow, low flow bypass, and again contaminant concentration and loads related to them as well. You can also look at storage time series, water level time series, that sort of thing, if that is something of your interest. Music also offer cumulative frequency graph and flow-based cumulative frequency graph. You can get a range of statistics from music, including mean annual load, node water balance, treatment drain effectiveness, and then you can actually compare that with water quality standards that is provided by your local authority. And all of these different time series and statistics can be also just obtained for selection of flow subset as well. Now let's discuss a little bit about application of music. Music can be used for both short-term and long-term studies. It helps assess how often over the long term receiving waters are exposed to pollutant concentration above a certain threshold. You can also get the long-term average annual pollutants load, which help measure treatment effectiveness, and that is usually what is done in Australia. So you will have some council guideline telling you this is a requirement, and you can just get that results from music. Music supports continuous simulation at various time steps from 6 minutes to 24 hours, and this flexibility actually ensures it suits different scale of stormwater treatment system. Now, in terms of the software application in scale, this can be applied at multiple scales from individual lots to subdivision and entire suburb. So you can see here I have a couple of pictures. I have also some background image has been used here just to give you some spatial context of the model. In this first example, it has been implemented for actually not even whole of suburb. This is one regional town. this is actually at a subdivision scale, and this is at lot scale level. So you can implement that at different scales, special scales as well. Now, let's talk a little bit about what will be the appropriate application of music. Music is a decision support tool, not a detailed design tool. It evaluates conceptual designs to meet water quality objectives and determine indicative sizes for stormwater treatment facilities. And it doesn't really size facilities for stormwater quantity or detailed quality management. So instead, it actually supports the sustainable urban design by simulating different stormwater strategies and helps user make informed decisions. So while music is a very powerful tool, it has its limitation. It doesn't rigorously cover stormwater drainage analysis such as hydraulic grade line assessment, other WCD aspects such as alternative water supply system, demand management. It doesn't cover non-structural based management practices such as planning policies, community awareness, enforcement. It doesn't consider operational and maintenance impact of stormwater treatment system. And because of these limitations, music should be used alongside other tools for a more comprehensive approach to water sensitive urban design. Thank you all for your time. I hope this session gave you a useful introduction to music and its role in stormwater management. I know some of you may already be very familiar with this concept, while for others this might be new. Either way, I really appreciate your attention and interest. If you have any question, I'd be happy to answer them. But if you need any more information after my presentation, I'll provide these slides. I think Brad is going to provide these slides, and we have our support email, phone number, and also website address here. And in the first slide, there is my email address as well if you want to contact me. Thank you, Brad. Over to you, and thank you, everyone.
Cool. Yeah, and thank you so much again for giving up your time. There's a lot to cover, and you've done well to cram a whole bunch of information in a very short period of time. And there's a whole bunch of questions that have come through. I might run through Shay Mackenzie from Oricon was very early on. And their query is, I'm not sure if this is sort of your department, Mukta, so no worries if you need to get back to Shay separately, but it's probably just the difference between Music X and Music version 6. So in Music versions, I'll just read out Shay's query. She asks, so why is a full rerun of all nodes in Music X models required, rather than just rerunning downstream of modified node as was per Music 6? If you can explain that, that'd be great.
Yes, so thank you for the question. Music X is completely rewritten on different code base, and because of that, we really couldn't have that feature, because this is again at the moment linked with our software as well, and that is the reason that feature is not there.
Cool. Awesome. Another question from Shay as well. And it's probably in relation to the research, and you showed some of the sort of references earlier, but Shay asks, does Music still implement any water-sensitive urban design research on treatment performance, such as bioretention and wetlands, et cetera, into the modeling software? It doesn't appear from the change log that any new research has been implemented in relation to performance since Music version 5.0, which was around about 2013. So that's about 12 years ago. So long story short, is there any updates to the bio and wetland or any other nodes in the last 12 years?
I exactly don't remember when it was modified, but bioretention node has modified. I think it should be around 2017 or 15. I really don't remember the data. Sorry about that. But it was modified based on Monash University research. So that is something fully modified. So that's what I can remember. For other thing, I think it is still the same, and definitely in terms of science, I don't think there will be much change, but it's still maybe we have to do some literature survey and then see if there is anything. But for bioretention, definitely we did a bit of change after Monash University research.
It's a difficult position for eWater to be in, obviously, isn't it? So if historically, it was a CIC for catchment hydrology, which gathered a whole
Yeah.
bunch of science, which was government funded and was fed into, I guess, the software
Mhm.
program. And eWater is obviously a commercial organisation. I think that eWater would love to have research being fed into,
Definitely.
yeah, but it's sort of not eWater's role to do that research, is it? But yeah, look, to help maybe answer Shay's query as well. Like I've dived into this as well, Shay, and I think it sounds like you have as well. There hasn't been any updates, yes, since around that time you mentioned, probably 10, 12 years ago. And the bioretention node itself only uses lab scale data. So there's no field scale verified data to, I guess, substantiate the performance of the bioretention node for conventional bioretention systems anyway. Yes, and obviously, but if people are doing that research and can fit into eWater, I think that would be greatly appreciated. And it's probably similar. You showed the before around the stormwater pollution generation data. There's obviously data from Hugh Duncan, the international compilation, which is 1999. So what's that? 26 years ago. The Rob Allison study, which is used to work out how much gross pollutant is generated per unit area, which is from over 20 years ago. That was a single study in Coburg in Melbourne. Um, I guess there's a real lack of science being fed into the software. Is there any, I guess, long story short, is there any plans to sort of try to uh, add more science in for eWater to do? Recognize you can't probably collect the data.
Especially like research itself, I don't think like eWater can do research as such, but we can collaborate with university
Mm.
and industry, so that is what we can do. And if there is like standard practice in terms of like if industry wants us to change, let's say we want this particular thing for gross pollutant modification and so on. And now we are in the position like earlier with Music 6 it was really hard, everything hard coded, and then we can't really change anything there. But with Music X, and also now we are also thinking of like having a new platform there. So with that thing, we have that capacity. Like if there is some science which is authoritative by everyone, we can definitely change the algorithm and improve it. And we are more than happy to like consider those sort of things.
That's awesome. Thanks, Mukta. Another question from Ranju Shapagan. Apologies, I mispronounced that. They ask, what is the similarity or differences between the interface of music and IQQM? I'm not sure if you can comment on that.
Oh, okay. So I think IQQM is like, so this is IQQM, there is a source model which eWater has. So source model earlier, like, there used to be various different models such as IQQM Realm used by Victoria, IQQM from Queensland and New South Wales. And then we have one source model, which is like, we call it National Hydrological Modeling Platform, where all the states can have come up in like same platform, and then it makes it easier for sharing models and all. And that is not related to music. This is more sort of like rainfall of model, planning model, that sort of thing. And maybe I haven't really seen how IQ chemistry looks like. Sorry about that, but that is where it is coming from, I think. And yes, we use source platform for music software as well, and that's why maybe you are feeling it is like very similar.
Cool. Yeah, awesome. Question around maintenance. This is, again, might be completely outside of the abilities
Yep.
of the software program, and you make the point very well. It's not a
Yes.
detailed design tool. It has its limitations as a conceptual tool, but it's a really well used tool now, obviously. And a question from Rowan Mooney. Barge, sorry, I'm not gonna. Rowan, let's call it Rowan. Rowan asks, does music consider the future maintenance of assets? As obviously some assets that may be hard to maintain, and that obviously reduces the efficiency dramatically. Is that something that music can model? I guess
It
from
doesn't. It doesn't
no.
model that thing. So when we you model, we usually ask like you need to take the average values as parameters, and also that average values means like let's say sedimentation basin, you clean it every 3 to 5 years. So you have to consider like when you design it, having enough space for when you clean it. So you will design it for like sedimentation deposition until 5 years. And also when you take like some of the conductivity parameters and so on, you try to take it average because music doesn't really consider like that sort of issue. And as a user, I think we should be really careful about if you don't really clean, maintain, then these different stormwater treatment measures are definitely not going to give you any benefit. And there are some devices, for example, let's say cross pollution trap or so, it will actually create problem in in future if you really don't clean it. Instead of giving you clean water, it will actually give you more pollution in the water. And maybe Brad, there are some instances where they are creating huge issues.
Yeah, look, you're spot on. Absolutely. Yeah, there's an assumption in music that assets are appropriately designed, installed, and maintained.
Yeah.
And I don't think really music can do much more than
No,
that.
no, in music and it's a cleaning, maintenance, operation. There are a whole bunch of side, and really need to be careful. And I think maybe it's somehow user. We need to educate user as well as a community.
Yeah, great. Yeah, great point. Another question from Don Delipa no, sorry, Don. Don asks, how do we verify the music node of a proprietary product? Full disclosure, conflict of interest. How do we verify the music node of a proprietary product if it has no user controls? A common answer is that the user must verify it independently. This is impractical in practice. Any suggestions?
I don't have any suggestions. I think it is out of my area. I usually suggest go and a lot of time I know some of the councils they do their own independent analysis. I don't know about how rigorous that analysis is again. So if that is the case, then maybe your council might give you some data. If not, you might have to go to your product manufacturer itself. Now we have this SQD process again there. I think that will somehow improve it as well. But I don't think I'm a right person to answer this.
Yeah, I can try to answer if you like. It's a great question. Number one, you should always ask for the model. At least it gives you the ability to check it, or at least give it to someone else to check. Always ask for the data to support any performance claim. There's a lot of, and that should be provided without any distribution restrictions. So you could give it to someone else to review. I think that's probably the two key things I would recommend. But certainly don't just blindly accept the performance claims of anyone. And I work for a company that has performance claims. All our devices are appropriately independently verified. We've got 5 that's gone through SQUIDUP, but separate to SQUIDUP, there's been a whole bunch of councils that have looked over them for years. But anyway, conflict of interest, obviously, there. Justine Barrett, greetings from Justine, CSIRO, University of Tasmania, Stormtrooper, legend. Justine asks, you actually said you can compare results for water quality standards. Which standards do you mean? And can you select water quality standards for different locations?
So I'm talking about how different authority do have certain removal requirements. Let's say for some of the council TSS removal requirement is 80 to 85. Similarly, phosphorus removal requirement 60 to 65. Again, depends on council. Nitrogen removal of 45%, and that varies from again council to council. So that is something you can compare. You can get the treatment run effectiveness data and then just compare it against that one. Or if there is any let's say requirement from the EPA or something like that, your flow shouldn't have certain contaminant concentration of once in a year, above that value. That sort of thing also you can compare.
Cool. Thank you, Mukta. And just a reminder, I'm getting a lot of questions coming through the chat without mentioning any names. I won't embarrass anyone, but if you could put them in the Q&A, it just means it's a lot easier for me to manage those questions, and I'll make sure we get them answered. Just a question from Winston Boone from Inertia, just a general question. So if they have technical questions regarding music modeling, is it best to email you, Mukta, or is there a support email address that they should be using?
I think any email is okay. Better to if it is come through support. If even I am not there, then someone can respond, but I'm happy to come to me as well.
Cool. Question from Han Jiang. They ask, what is the recommendation for a music modeling for a council that doesn't have a music link? Should we use another adjacent council's data or get other available 6-minute timestamp rainfall and PET data?
That's a very specific question. I think I can answer a little bit there, but not much. Maybe I have to talk to you separately on what are the process there, because especially climate data will be very local to your area, and so your soil properties, and that can be again very local. There are guidelines state-wise guidelines if your council doesn't have any guideline for music. So I will be starting from that point, and then again, as I said, soil parameters, especially for rainfall, runoff generation, and so on, will be still might be a bit different. There is New South Wales music modeling guideline as well, which gives you a bit of parameters range, especially on source node for rainfall, runoff generation, range for different type of soil. So I will start from that point and then further try to explore. But I think this is more sort of offline conversation thing. Please email me. We can discuss further based on your catchment itself.
Cool. There's a lot of questions around GPTs, and but Dan Rhodes has come through. Dan Rhodes, greeting from Optimal Stormwater and Stormwater Queensland Committee. Dan Rhodes asks, high performance GPTs based on the CDS technology, like this Ocean Save, store pollutants outside the screening area, allowing them to maintain a consistent treatable flow rate as they fill up with pollution. In contrast, lower performing GPTs store pollution within the screening area, causing the treatable flow rate to decrease as they fill up with pollution. Why does music not differentiate between these two different types of GPTs, as it may lead to low performing devices that are difficult to maintain basically being said, oh, they're equivalent and installed basically by councils? So is there any scope within or any interest for music or eWater to basically differentiate between the two general types of GPTs, high performing versus low performing GPTs?
That's a very good question. Especially with generic treatment device, we haven't done anything there except giving certain components to help, and just user has to define their own thing there in terms of performance, treatable flow rate, and so on. But if I think I'd be happy to get some feedback if we can improve the generic treatment node for that purpose. We'd be more than happy to consider that. And most of you might know we are now at the stage of developing some roadmap for future music, and we'd be very happy to consider all those things. So my suggestion would be if you can go through generic treatment node, and then if you can let us know what exactly you require for us to improve, we are more than happy to take that.
Cool. Russell Cadman's just reminded me that in terms of bioretention research, the comment I made before, he says there's obviously Blacktown City Council are undertaking a field scale bioretention monitoring project in collaboration with Ocean Protect, ALS, and New South Wales Government. So hopefully there'll be some sort of data that come out of that could possibly be fed into the bioretention node. So thanks for that reminder, Russell. There was a question around, probably it's more in relation to modeling different types of pollutants, I guess you'd say. So obviously the default within music, you can model TSS, total phosphorus, total nitrogen. Emerson Bradley asks, I think Emerson's from Northrop, he says, we had a project which was attempting to reach specific Green Star requirements for pollutants which were not being shown in the results for music in our model. Is there a way to calculate total petroleum hydrocarbons and free oils using music?
The answer is yes and no. So first thing is if you want to model something else, you can definitely, there is a way to do that. However, I think in music, if you see that contaminant generation parameters, so from source node, first thing is you need to have certain way of giving okay, mean value, standard deviation, whatever it is. This is the contaminant that this particular type of land use can generate, and we need to have that data. So I haven't gone through a whole bunch of literature source, but there might be already some data or not. So if you have that data, which type of land use can actually have various generation for your different contaminants, then yes, you can do that. So first thing is in terms of the contaminant generation. Next thing is treatment. So again, for TPT and TSS, we have certain research done during CRC time, and it will give you already how different contaminants, typically those three, are removed from your treatment devices, but not for other contaminants as such. So again, you might have to modify things there, and then that requires calibration and validation as well. So if you can do that, yes, you can use music to do so. Otherwise, I think that's again some questions for research.
Yeah, cool. Question from Gopal from the city of Clarence, I think. And it's probably a similar question to what was being asked around, I guess, fudging the numbers, for want of a better word, playing with a model where you probably shouldn't have, and to get your desired result. So Gopal asks, we have seen input parameters are changed to achieve a desired outcome. Let's call it fudging the model results.
Yeah.
How do you feel about music's, I guess, flexibility that allows this? Should there be more default parameters and limited ability for users to change these numbers?
So default parameters, again, default varies based on where you are. It is so localized, except some of the advanced parameter in the treatment node. I think we do have one feature in music link. That is where and we can extend that. We are thinking of extending that feature for most of the councils. So we are still not there. But what happens if you have music link is we have a particular authority guideline that is embedded within music. So once you open your scenario or create your scenario as a music link scenario, then it will have already the default climate data loaded based on that particular authority, and then it also preloaded your source node default parameters, and same with your treatment. It will have certain default parameters, and once you run the model, it also produces music link report, which gives you a list of failed parameters if it is not within the range or not really following the values. So I think that is the better way to do that.
Yeah. It's music's flexibility is really great, but it's also, it does leave it open
But then
to abuse.
that is something you can't really make the model black box type either.
Yeah.
There comes a bit of problem.
Yeah, cool. A question from Amrit Pun Magar they ask, is music only used for simulation of rainwater runoff? Can it be used to simulate the flow in a channel like HECRAS?
No, not really. Music is a conceptual model mainly for stormwater treatment, so it doesn't do any sort of drainage pipe design or that sort of thing. Not at
Cool.
all.
Yeah, cool. Question from anonymous attendee. They ask, is it appropriate to use the detention basin node to model a concrete detention tank?
Okay, that's an interesting question. Maybe I need a bit of
I can help if it assists. Yeah, look, yeah, possibly anonymous attendee. It depends. That tank would need to be appropriately cleaned out, etc. So it's not just just something that's there. If pollution does accumulate, it will need to be cleaned out. But often the detention node is used upstream of like a cartridge system, and the detention is actually modeling the performance of the overall cartridge system. So if you're modeling a proprietary asset with a detention node and a generic node, you don't want to double count the results. So you can certainly put in a detention node, and there's no to handle the hydraulics, but you should specify the K value to equal 1. So there's not basically a double treatment happening. So essentially modeling pollution removal where none actually physically exists. I know it's a bit of a complicated answer. It's a little bit above the, I guess, the fundamentals focus we're looking at. But if you want to talk more, just give me a shout.
And on that, I know some councils actually don't accept any treatment from detention basin at source, and they have their K value 0 set up.
Cool. Yeah. Question from Sean Quilty. It might be a question from me, I think. Sean, one of our amazing presenters from Quilty Engineering Group. Welcome, Sean. He says, so music nodes for typical bioretention does not have a field study data to verify. He asked, does Ocean Protect's Filterra systems have field test data into the music nodes? If so, this would give more confidence to use Filterra nodes over traditional bio. Yeah, look, so Sean, I can answer that. So we do recommend, as per the SquidUp verification, to use the bioretention node with adjusted properties to modeling Filterra bioretention. But that performance has actually been verified in the field. So we and Ocean Protect and the SquidUp review has actually compared results from the model versus field scale data, and it's actually a really good match. If anything, music is probably underestimating the performance of Filterra bioretention. So long story short, yeah, there is the field scale data to verify the performance of Filterra. To the best of my knowledge, I'm not aware of any such verification for conventional bioretention. Again, Sean, that's a bit of a take-home question. If you want further info, just give me a shout. Look, we're quickly running out of time. One of the questions also was, I think you've blown a few people's minds today, Mukta, and they want to know more. One of the questions I have here is, where is the best place to find more training on music? Where do people find out more and how to use it better, essentially?
So we actually run music training almost like every month. So we run music fundamental training, which is 2 days full day training. In eWater website, you can see clear detail of that. We also send emails about our trainings. And we also run this Music X transition training, especially for our Music 6 users who wants to now adopt the Music X itself. And then another training we run is we also run in-house training based on request from different organizations as well. And you can get all this information on our eWater website.
Cool, great. I've had this question a couple of times. One from Winston Boone from Inertia, another one from Hip Lu, I think from Vietnam, which is awesome. They asked the same question, and it's probably the most common bugbear I hear is the music results change from one simulation to the next. Yeah. You might run a model, get some results, open it up, later on, and the results might be marginally different. And I'm not sure if you covered this in your preso. Do you want to explain why that is?
So what we do is if you look at music source node where we generate the runoff pollutants, we use stochastic generation method. We don't use mean method. Instead of mean, we use stochastic. So what does that mean is we have a curve where you provide mean and standard deviation of the generation. Why we do that is, if you look at especially contaminant generation, very uncertain. So instead of, and to actually somehow cover that uncertainty in the tool, we use the stochastic method. And what this stochastic method does is, from your curve, it will randomly pick up values when it runs the model. And because of that, there might be a slight difference. And again, that difference might be high if you run it for shorter time period. And that's why our recommendation is run 6-minute time step, 10 years at least. And one of the reason behind that is and altogether then that randomness will be a bit less if you run model for more time steps. And this is because of that stochastic generation method we use in music. You can also use mean, but we don't recommend that.
Look, we've had a couple of questions, and they're a bit sort of off topic. So one of them was around modeling litter baskets upstream of bioretention. Winston, what you're talking about here, and apologies, you can't see the question, but it's a very specific rule that some councils apply. It's probably best to talk about that offline. Probably just best to email me and I can talk to you further. Emerson Bradley, the other comment around hydrocarbons and the Green Star target. Again, probably best to just contact me about that one. We do a lot of Green Star stuff, obviously. So they essentially recognise that the targets aren't appropriate, but there needs to be some sort of explanation as to why that is the case. But long story short, best just email me or contact me offline if you're keen to know more. And we are flush out of time. So before we skedaddle, Mukta, if you can just bring up your screen with your contact details as well, that'd be much appreciated. But I just want to thank everyone for dialing in today. Uber popular session. Like I said, 641 registrations where I think we had about 450 people dialing in or thereabouts. If you have any further questions you'd like to ask Mukta, please contact her via that email address or phone number you can see here. And obviously, she has indicated that music training is available as well. So if you're keen to learn more about how to use music appropriately, I'd highly encourage you guys to jump on the eWater website and actually book yourself in for a training session. They're super helpful. I actually don't think it should be like a car. You shouldn't have an ability to drive the car without getting an appropriate training and license. And I think it should be the same thing for music. I think if you are using music, I think it should be mandatory you do some sort of music training, and eWater are the guys to get that done. So again, I'd highly recommend everyone on this call, if you're keen to know it more, please jump on the website and register for the one of their training courses. But again, thank you so much for everyone for dialing in, and thank you very much for Mukta and eWater for sharing your time and expertise today. I think it's fantastic, really appreciated, and hopefully we'll catch up in person sometime soon.
Yeah, I think I can see you at Queensland Summit.
Sounds
Yes,
good.
I'm joining that.
Sounds good. And just a reminder, folks, we've got a whole 11 more stormwater fundamental sessions. So if you're keen to register, jump on the oceanprotect.com.au website /events. So please register for the next one. But I hopefully look forward to seeing you guys soon. Again, thanks again for Mukta. Enjoy the rest of your day.
Yeah. Thank you, Brad. And thank you, everyone, for joining.
Thanks, guys. Bye for now.